welcome to part 3 of my learning video. So last time I did some edits of the code, but I didn't record it, so I'll go through it briefly. And I'm glad it works better now. So if you look at the script, you can see that, well, not the script, but the game, you can see there is a banner that shows what generation it is, what species it is, what genome it is, fitness and max fitness. We still have the map as before, but now the coloring of the buttons A, B, X, Y actually depend on whether you are clicking the button or not, or whether the AI is clicking the button or not. And oh yeah, and then you might see a text in the top left that says I am in display genome. That's the function, because I was struggling with part of the code. I put some text printing lines in there, but nothing is being printed, and I was really confused of whether or not it's being run or not. So let's look at the code to get a little bit understanding of it. I don't know if it's gonna crash. So what happened was, when a genome increases, I think it's supposed to do some mutation. Let me just pause it. It's supposed to do some mutation, so the AI is, creating something new. But because I kind of simplified the code, right now it's not creating anything new. It's just creating the same thing over and over again. That's why you see nothing's happening, I think. And then there is a max cap of 300 in the genome for one species. So what happens is, if you go through all the genomes and you're at the max, then we'll reset it to 1 and increase species by 1, or generation by 1 actually. Oh yeah, it's you go through the genomes and then you would go to the next species. But if there's no next species, then you would increase generation by 1 and you start from the beginning again. But I kind of simplify the code for creating a new generation, so it kind of broke. Last time when I just sit and watch it go to 300 and it just froze on me or something, which makes sense because you're telling it, hey, you can't do anything when you're at 300 genome, but you're not like doing anything to set it back to 1. So it's just in the stuck mode. Okay, so let's look at the code. The parts that I added. So what I realized is, I realized I'm streaming the wrong file. It should be this one. Okay, so what I was confused with is, at the beginning, how is anything being initialized? If you look at the while do code, which is what's gonna happen when you run the code. So first you set the background color, nothing special, and then but here you see that, hey, it's setting species equals support.species. So it's thinking that there is already a pool species and a pool current species and species genomes like somewhere, but we didn't even create it. So I was confused about where that would have been, and it turns out that there are 2 places where it's mentioned. One is here. When you create the forum, you have a button that called restart, and it initializes the pool, which calls a function initialize the pool that creates pools and basic genomes and stuff. But then I also realized there is a bunch of code here that says if pool is null, then then you initialize the pool. So this happens even before we have the while true do. But what was confusing was I tried to print stuff, but I don't see it, so I wasn't too sure if this is even being run or not. If it prints, then yes, I know it's being run. It's not printing, I don't know if it's being run. But the thing is, later I realized that to see something in display, you have to depend on the code, something like mu frame events, which basically tells the system, I'm guessing this, it tells the system that, hey, you do this, and then the frame is gonna go to the next frame, and then you do it again, and then the frame goes to the next frame, and you do it again. So that's why you would see the text in here, because it's being printed for every frame. But for the code here, do we see anything that tells it to keep printing it? No, it just runs it one time, and then the next frame it's disappeared. So same thing as at the very beginning, you have a bunch of code here which says, get the game information. If the game name is this, then you set a file name and you set button names. So I tried to put the print screen here. So here I obviously know that this code is being run, because later in the functions we call button names, and this is where button name is being defined. And when I put GUI, the print, what's it called, print text code here, nothing shows up. Like, even though I know this is for sure being run, it's still not printing anything. So that confirms that it doesn't print unless it's in the while do loop. So that's why we have confirmed that the information were being, all the pools and genomes were being initialized. Where is the code? Here. Yeah, we're actually being created here, even though there was no printout. And so after you create these things and initialize the run, and here is where you also create some network. And another thing that I realized was, in my loop, in my original loop, I had these two lines commented out because it was broken at the time, because I didn't have the function to create the pool or the genomes species. So I had it commented out, and that's why later when I run this code, display genome with a genome, nothing showing up because you don't have one. This wasn't even defined yet. So now we created it and it runs. So this is really good, and we can see on the top that the genome numbers are increasing, and we're actually printing them. So there are a couple more things that are added inside as well, true do, but they're more straightforward. They're more about printing certain things on the screen. This thing for, oh yeah, so I don't really care about this anymore. So this is print network. So this code here specifically is to print the network, and currently what we have as a network is wait, why do I have to that is, wait, it's not this one. Wait, is it because it's paused? Yeah, it's because it's paused. Okay, so so the banner on top shows the gene species information, and if you hide the banner, you hide everything. And then on top of that, you have show map. So the map shows the buttons, and there's a little square which we're gonna draw the enemies that we see on the screen. Hopefully it's not gonna crash because it's gonna get to 300 soon. But anyways, the box and the buttons, these are the network, which is what we draw here, display genome. And the top part, the banner part with the generation 0, it's at the bottom. so we'll show that later. So these are setting the joypad to controller results. If the frame is, I think, multiples of 5, then you do evaluate current. So every 5 seconds or 5 frames, you evaluate current. I don't remember if I have anything in here, maybe. So here is to track Mario's furthest distance on the map, because X would be the overall how far he had been, and we will, I guess, give him more time. So here you see that timeout equals timeout minus 1. So every time you go through the loop, you are subtracting your timeout. But then here, if you see that, hey, you're actually making progress, then I'm gonna reset it so you have more time to do whatever you're doing. And this is timeout bonus. So basically, if we look at it, it's 3 blocks. This is one block, it's an if statement. And then we have a block here, and then we have a block here. So this block is where we show the banner information, because you can see they're drawing the text, generation, a number, species, a number, fitness, a number, max fitness, a number. So this is exactly what the banner is showing. This part is calculating the percentage of genomes with fitness not equal to 0. You have measure, you have total, you go through the species, you go through, for each species, you go through the genomes. So total, it's going to calculate how many, I guess total it's probably, maybe this is in the whole generation, because if you are looping, you're adding total for all the species for all the genomes. So this is total genomes in all species. And then here you're saying, hey, if the fitness is not 0, then I'm gonna to add 1 to measure. Not too hard. And we use it later, I guess, in the percentage part here. We have like a percentage to see how much is being measured. And then let's go back to this section. This section, I put some comments here as what I think it means. We can just briefly regard it as, if you timeout plus timeout bonus. So timeout is gonna keep decreasing is gonna be negative. You spent too much time here, we're gonna reset. Then yada yada yada. We're gonna initialize the run. So I think it's going to record certain things and say, hey, this is the end. I'm gonna calculate some fitness and update the max fitness. If you're, you are going to be timed out, then we're gonna record these things and we're gonna display and then we reset the species and reset the genome, and we calculate or measure a bunch of fitnesses. Actually, this one is to check if they are measured or not. And then we initialize it. I'm not too sure about why you would check here. In before everything else, where will you do fitness, updating the max fitness and stuff. Because I think this is only updated when you spend too much time. Oh, I think now I think of it, I'm guessing, Mario's gonna, in one iteration, Mario's gonna, do things, right? It's gonna jump, it's gonna walk, and when we do the loop, we are letting him walk and walk and walk, and this is when, oh, this iteration is done. He's not doing anything more. He's done with the game. This is the max fitness that he is going to get. Unless he walks backward, like he technically could walk forward and then walk backward. Unless the game prevents him from doing that. Like if you oops. Oh, I don't think I can even play it because it's just loading it constantly. So the question is, yeah, actually it lets it walk backward. It's not like, whoops, I died. It's not like it doesn't let it walk back. But that's not too important. We can look at it later in more detail. Let me pause that. So we kind of went through the code for within the while true do. So we display the generation information, but the question is, if I want to show more with the neural network, how are we gonna show the rest of the information, the nodes, the lines, active lines, and which buttons are active? Well, none of them are active right now. So let's look at, how long did that take me? 18 minutes. Okay. So some other thing that I added includes some code that is being used in the bottom section. So fitness already measure just says if the fitness is actually is not 0, not close to 0, it's not 0. True means measured. That's what already measured means. The next genome is basically just adding the index by 1. If it's the last item, set it to 1 and then increase the species. If it's already a last species, then create a new generation. And then evaluate current is using the getting the what controls is being used. So we would run evaluate network with the inputs, and then we'll get a controller. Whether if this person clicked left and right, or what buttons they're clicking. I think I can make a note. So what I think is, when you ultimately we want to know a yes or no for the buttons, right? It's yes for up and A, then he's clicking up and A at the same time. And controller is kind of the result of what is being clicked. We could technically print the controller results or print the ones that are true. So that can be added later to know that, hey, you are printing this and not that one. What else? So new generation, originally I kind of have it pretty empty. I just have it as like a placeholder function. But as I said earlier, it kind of broke the game when I hit the max cap of the genome and I didn't increase the generation, so I went back and added the code. There are a lot of subcodes, subfunctions in here where they're like removing weak species and they're calling the species. So I removed those. So right now we're just blindly doing something as simple as possible, just to get the code working first. So here, this is like cleaning it up to remove the not so good branches. But here we are just calculating the average fitness for the species. Oh, I actually need to I need to check my Lua console because so what happens is you display the information at the top, genomes increases, and then up to 300, it's gonna go in the next generation section. It's gonna know, hey, I hit the mark. I need to get a new generation, so it comes in here, and we need to make sure the code in here works. And at the end of the day, we increase generation by 1. We reset the species, etc. And then the code moves forward. So now it's telling me that, hey, calculate average fitness. I don't have that defined, so we have to define this one. And sum equals the total average fitness. Children, and for the number of species, we're gonna set this one species, and then we're gonna get the average fitness of that species, divided by sum times population. So in a sense, I am not entirely confident with what the math is at this point. I'm just kind of believing that the math does what it's supposed to do. I want to focus on the AI training part more, and maybe dig into the calculation of, oh, how did it calculate average fitness? How did it accumulate it later? So we have breed. So there's a couple of functions here that we need to do. Breed children. This basically, you have a children as a blank list, and you are breeding children, and then you're putting it inside this children. And while the number of children and the number of poor species less than population, so you think you want more children, I guess. Actually, you want more species, then you keep breeding them. I think I'll add it as a comment. Keep breeding children slash species until its population size. And then for each for the number of children, have a child, create a child. A child is one species, and then we add to species with the child. So this part we are adding each species to the network, I suppose. So here you're creating a bunch of children and species, and here you're adding the species to whatever, to the genomes or the network. It depends what this one does. Let's see. Okay, might be just faster to do a oops search. Where is it again? I'm lost. I don't know where formula is. I think we're looking at new generation, so new gen. Here. And we're looking for add to species. Here. So what add to species does is check if the genome is the same species. If so, add to the species. So we are adding to a species.genome. So what we were doing before was we have species in a list, but they were not in the list. So they were not in the species .genome. So cool. Okay, so now we go back here, calculate average fitness. See if we have it, and we don't. Yes, we don't have the function for that. So I'm gonna search it up here. So this is the function 30. Calculate average fitness for a species. So for the number, all the genomes in there, you are going to get a genome, and then you're going to add it in a global rank. Gonna add the global rank of the genome, and then your average fitness is the total divided by the total global rank divided by the number of genomes. So sum up in species and average. Okay. And let's see. Let's try to run and see if the MarI is broken or not. Oh, it's not active. Oh, I think I might have missed some code. I don't know if I have to restart it. Oh, actually, this one. So this is the map. This is the genome, and we're checking if it breaks. So, and while it's doing that, I want to check if the oh, destroy form. So the code here, the actually all the way here, this one destroys the forms. So when I was running, every time I run a script, a form with a window is gonna show, little window is gonna pop up, and this one it destroys it. It says, hey, if I exit, it's gonna destroy it, but somehow it's not working anymore. So I don't really know. I think like if I restart my script, it's supposed to destroy it, and it was working last night. It's a lot. It's really tedious for me to keep closing and opening the windows. Well, not really the opening part, but closing. Every time I rerun, I have to close the old window. La la la, la 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 la, la la la. We're just chilling, and waiting for it to hit 300 and then see what errors pop up. Although I probably should check the code to make sure, you know, I actually have breed the child. Actually, speaking of that, let's pause it. Okay, I actually have breed child. So what breed child is, if we want to cross over, then we use the crossover code to create a file that's crossover. If do not, then we just copy genome, which I don't think I have either one of them. Yep. So let's do that. So crossover is how you combine two two genomes together. I think it's really good that we did it in sessions. Obviously, you can't do everything at once, but it's good like we have a easier version, simpler version, and then adds on, make it work. So crossover, make sure G1, is that L or 1? I have no idea. Probably 1. G1 is the highest fitness, so if you know, number 2's fitness is higher, flip it around. And then little child is a new genome, and then innovation 2. So this is actually another function. Wait, actually no, this is a list for all the genomes in number 2. You have a gene, and then you have gene.innovation. Gene.innovation. I might have to look it up. What I think it is it's a property of a gene, and it's 0 first. Okay. It starts with 0, and you set it to a gene. Sure. So if multiple genes have the same innovation number, then I guess you only pick one of it seems. For the list of genes in the first one, you have gene 1 is what gene here, gene 2 is a gene in number 2 in this list that we just created. But we use the use the innovation number to decide which gene 2 we're gonna get. I'm kind of thinking it might be like, as mentioned in the book, the history number, where, or like its origin number that it came from. Two genes with the same origin number came from, are basically the same thing. I'm not too sure. If gene 2 is null and referendum 2 equals to 1, so I guess this is like 50% chance, and gene 2 is enable, then you would copy gene 2 into the gene, otherwise you'll copy gene 1 into the gene. So if gene 2 is empty, but then gene 2 is enabled, then you're going to, oh, actually this is not empty. If gene 2 is not empty, then you're gonna copy gene 2. Oh, hello, Linted, how you doing? Cat? Aw, that's a cute name. And then child's max neuron is math. So the max neuron of G1 and G2. Couldn't think of name, could it wouldn't let me use blush again. Oh, I don't think it's blush. Could be. Yeah, I think Ka is very representative. Oh, mutated rays. Mutated rays. Oh, this is like kind of hard to figure out. How good then? Yeah, it's really good. It's on point. Oh, this is a little bit confusing because I don't really know what the idea is. Like, how does innovation work? It's almost like I have to go into, hey, how did you even get innovation the first time? What does it mean? And then here figure out, sure, you're copying gene 2, but why? This is a function that swaps the genes of the better one with the worst and randomly introduce mutation. Ooh. Can I just copy that paragraph? Well, I wouldn't say it's swapping gene of better one with the worst. I'm guessing you're talking about this part, right? To make sure gene 1 is always better. But the thing is, if gene 1 is better, why would you copy gene 2? Yes, that's the question, and I need to figure out what innovation is used as. Because I'm guessing, let me find the book again. So I'm guessing it's like a origin number. Like, I guess it indicates that, hey, even though, you and I look different and we have different nodes, but actually my number 5 is the same as your number 5. But you have an extra 4 and a 3, and I have a extra 7. That's what I'm guessing. What did you say? The first block swaps if G2 has better gene. No, I think G1 has. Yeah. Second block makes copy of the worst gene. Copy of the worst gene into innovation. A copy of the worst gene into innovation. What do you mean by into innovation? I get the copy part, which is right here. If gene 2 is enable, it would be nice to have like a visual representation of. I need to turn on a heater. It's kind of cold. Be back. The first for loop sets innovation 2 to be the worst of 2 genes because first block, yeah. Innovation 2 is that is true. If I suppose innovation is what I think it is in this diagram, as in like an identification of whether something is the same or not, then innovation 2 is the worst gene, and number 2 is the worst one, and so even though it's a worse one, if it's enable, you will still keep it. So for all the genes from 1 to all the genes in the first one, I am kind of thinking, well, I guess math.random 2 equals to 1. That means there's like a 50-50 chance, right? So if gene 2 is enabled, then there's a 50-50 chance that we'll copy gene 2. Although, one thing I'm thinking of is if gene 2 is innovation 2, so basically gene 2 has the same innovation number as gene 1, then they are kind of the same thing. But they just happen to be in the worst genome, I would kind of think. So we can like look into how innovation is being used later. And then this one is the mutation part. So let's say they're the same. I don't know, maybe they're different. I think it's making sure to compare the same 2 genes. Yeah, this is what I'm thinking. Just not entirely sure what kind of information is in the gene to make them different, or are they actually the same? You don't grab the hair color gene twice. Yeah. Okay, so I can add that comment. To get same gene for comparison. But it's like if they are quote unquote the same, but somehow they're still different, that you would pick either one to grab, you know. Because if they're the same, then you would just grab one and go. Must be a trait that gene controls. Yeah. What does IMHO mean? So one way I can do is look into the innovation thing to see how it's defined and stuff. Or I keep going through of this and then we can look at it later. In my honest opinion, I see. I want to go through this and then we can look into innovation later. Just assume they're the same for now. So child dot max neuron. So child is a genome, and a genome has a max neuron. And we check is the first one or the second one has more neurons. Actually, the thing a bit weird is, but here we were checking the fitness, right? So we know G1 always have the higher fitness. But then here we are doing innovation indexed by G1's innovation. So that means if G1 actually have less neurons, then I don't care about the extra stuff that G2 has. I only care about what G1 has. And then out of the stuff that G1 has, we do a 50-50 chance of if we want to take from G1 or G2. I think that's the idea, right? So I guess my question is, child.max neuron, why does it care if X what's G2's max neuron if I am only comparing by G1's gene? It's like maybe G1 only have 5 and G2 has 10, and I'm just going through 1 to 5, and then here I'm like, oh hey, by the way, G2 has 10 max neurons. Would that mean that we would end up with maximum? Yeah, I think so. I actually don't know what this is being used for. At least it's not being used right here. So I guess we can add a comment. Questions if G1 has less neurons than G2, then we end up with bigger number. And then the next part we have mutation rates, G1 dot mutation rates, and then child's mutation rates, mutation equals to rates. I just noticed the MarI on the left. This is a ML algorithms to generate errors. Yes, and it's a generic method of developing neural networks. So you kind of structure things like, I don't know if other methods also structure it like cells and neurons. Not one. There's neurons and there's genomes and genes. As this one, but it's trying to start with a smaller system and then through some mutation grow into a bigger branch, and making sure that it's always a better one when you keep a bigger structure. You're not keeping a bigger structure for no reason, kind of thing. So this one it's just something about mutation rate, like, yeah, sure. I think we can leave it. So copy gene is, we don't have the code here, so I'll copy the code over. I'm thinking I wanted to see a little bit mutation. Obviously the code I have right now is a simple version that basically is not doing anything because there's no mutation going on. I might remove some parts, or I might ignore some parts and just go for the mutation to see the change. Probably makes a new instance of the garbage collector so it doesn't get thrown away. I thought they're copying as a new one. I don't think it's copying the garbage though. It's copying the one that it wants, right? But yeah, it just has these features and just copies it. Cool. Going back to where we were. Have to go back. I don't know what name it was under. Crossover. It was under crossover. So I think we have most of the stuff. What is some other thing that we need in the function? Generates. Have to do homework. Okay, thank you for coming by. It's pretty cool. Chat about it. Thank you. Okay, so here, breeding the child. Copy genome. We don't have anything. I think the next step that we want is to get a little bit of change going on, that you will see, hey, it tried to do this and it did that. And actually before that, maybe we want to draw it out so then you can actually see like what notes you have. And okay, 11. Oh, it's 12. I'll need to eat soon. Let's get the copy genome over. Should be pretty straightforward. Number 11. Right here. So it's a new genome, and then for all the genes, you insert the genes into it, and then you also get the features of the genome. So this is just copying it. Cool. Okay, so now we have copy genome. Went back, I think 33. Mutates. So I think we are kind of done with most of it. Mutates. Let's see what we have for mutates. So for breeding the child, actually commented out for the other one. So we don't have the mutate function yet. Oh, I think the mutate function was basically calling all the other functions to say, hey, if you want to mutate it, then you do this. You want to mutate, you want to do that. So what I'm gonna do is I want to 1 hour already. Oops. Find. I'm gonna comment it out in the code and then see if it runs. So it should fix the new generation problem mostly. Okay. So we just wait for it to keep increase to the genome. Okay. So it thinks total average fitness is a null value. Total. Oh, here actually species is a null value. I kind of added a lot of stuff. It might be hard to figure out what part is talking about. So the fastest way is to do. It's definitely in here. So we calculated that the thing species is a null value. I am going to simplify it by. There's a couple ways to simplify it. One is to, so basically what this is doing is, hey, you're adding to species. You know, you don't really need to do that. You're breeding a child. You don't really need to do that in the simpler version. So this is saying, hey, if it's less than the population, then you keep breeding it. So we can also comment it out. This is calculating it, which is fine. And then this part is breed is a number, and you do a insert using breed child. So then after, at the end of the day, you add it to your species. I might take it all out. I wonder if I can do a multi. Yeah, cool. Good thing I checked the. I will. Yeah, I'll comment this block out and I'll just do, hey, pull generation equals +1. Yeah, and then let's see what happens. Oh wait, let's see. Okay, so this still thinks species is not valid. 757, is it corresponding to the row number? 757 around here. Species genome. Restart. Okay, let me see. Invalid arguments to method call. Something is broken and I'm not too sure what is broken. I'll do some debugging and then we'll join you in the next video. Thanks for watching.